Hello everyone, I am Mahitosh Mahip. Welcome to Aribhat Ashram. Today we are going to have a discussion on some of the questions asked in Civil Services Examination in 2021. And we are trying to give solutions, and these solutions are not just merely mechanical solutions. We also try to delve deep into what do they mean and how we try to verify our answer. So it is we are starting with the Civil Services 2021 question of ordinary differential equation. And if you would understand that these kind of questions are prone to errors. Okay, so how do we not just only solve the question but also try to verify our answer, and that's what we will see in this question. So this is your question number 5a, asked in Civil Services Examination. D square y by dx square plus 2y is equal to x square e to the power 3x plus e to the power x cos 2x, and this was asked for 10 marks in compulsory. Now, first and foremost, we need to find out the complementary function. So if you write the complementary function in terms of auxiliary equation, you can write it like this. So we get the roots as m is equal to plus minus root I. So our complementary function is c1 cos of root 2x plus c2 sine root 2x. So in no time we get our complementary function. Now we want to find out the particular integral with correspondence with x square e to the power 3x and e to the power x cos 2x. If you would look into this right hand side, what you will understand is that it's having a composition of two functions. That is, one is your algebraic, other is your exponential, and one is exponential, another is your sinusoidal. So it has to do something with regard to shifting property, and mind you, shifting property what we use in ordinary differential equation and what we use in Laplace transform, those shifting property are completely apart, poles apart. They're completely opposite to each other. So that is what many students get confused in examination hall and they make errors. So we are trying to not just solve the problem but also try to where people have gone wrong in test papers and how do they behave in an examination like situation. So complementary function is c1 cos root 2x plus c2 sine root 2x. Now many of the students of classrooms and elsewhere, they have sent us their solutions in examination condition, and to some of them they have done silly mistakes, and mistake is that this is 2 and they have thought of this 4 or whatever and they have not written as root 2, rather they have written it cos c1 cos 2x plus c2 sine 2x. Now once you make a fundamental error in the beginning of the question, the majority of the marks is gone then and there. So now we will try to find out the particular integral with regard to x square e to the power 3x. Okay, and this is your d square plus 2. Now if we want to do the shifting, we will take this outside and we can write this as x square upon d plus 3 to the power 2 plus 2, and this gives us e to the power 3x into x square by d square plus 6d plus 9 plus 2 is your 1. So there are two ways to go about this. Okay, so one of would be using the use of binomial theorem and try to use that. Another would be used for answer verification, which I will tell you in a while. So first thing what we try to use over here is that we try to use this 1 plus d to the power minus 1 using binomial, 1 minus d plus d square, and so on and so forth. So over here, if you would look, we will try to express it in the desired format. So this P1i is e to the power 3x, and 11 was common, so we can take 11 outside. This is 1 plus 6 by 11d plus d square by 11. So if we try to write it down in terms of binomial, we can write this 1 by 6 by 11d. This is your minus of d. So this is, and if you look into, we are having x square, so that will be looking for only the d square. So if you just square this up, you'll get 36 by 121 d square, and remaining is not of any use to us. So we can write this as 36 by 121 d square, and this is your x square. So once we try to find out this value, this e to the power 3x upon 11, and if we try to compare over here, so this is 6 by, now this is 36 by 121 minus of 11. So if you do this calculation over here, this is 25 by 121. So we can write this as 25 by 121 d square. And if we close this bracket here, and this is x square, so this will give us our answer. Now if we can move further and try to write in the next page what we have here, so let us try to copy what is here. Pi1 is equal to e to the power 3x upon 11 x square. Okay, so we'll just try and write what we have got here. Okay, so this is something we will just look into what we have boiled down to. That is 1 minus 6 by 11. 1 minus 6 by 11d plus 121 to 25 d square. Alright, now if we will decompose this further, this will give us e to the power 3x upon 11. This is x square minus of 2, that is your 12 by 11x plus 25 into 2 is your 50 upon 121. So this is what we get, our answer as regards Pi1. Now we will just verify in a while as to this is the solution or not. Okay, so we will focus here more so on our answer verification. That is answer verification here. Answer verification at this juncture. So we have already shifted this. Okay, and once we shift that, what we are left with is your x square. Okay, 11 plus 6d plus d square. Right, after the shifting, that is what we have got. Now simple division in rule will give us, because we know the differentiation of a function. Similarly, the inverse of d operator, which is a differential, if we take the inverse of d operator, that gives me the integral. So we are using this as our approach to division method. That is, so what should be multiplied with 11 so that I get x square? And it's not simple, these operators are there. So I have not introduced operators. Start with the value that is constant. So I will rather write this as x square by 11. So this is your x square. and this plus 12 by 11x. Now this is how much? 2 by 11. You see, we are having derivative or differential. So this is 2x by 11 into 6, 12x. This is done twice of differentiation, that is 2 by 11. Now this is your minus of 12 by 11 x plus 2 by 11, and I need to write the minus sign here as well. Okay. Now what should be multiplied so that I get minus 12 by x? Certainly I should multiply it by minus by 12 upon 121, because 11 by 121 will be 11. Now I should also multiply with x. So this is your minus of 12 by 11x. What about here? This is minus of 72 upon 121. Okay, so this is how much? 72 by 121. So what we get here is your minus 2 upon 11 plus 72 by 121. This will render us 121, and this is 11, that is minus 22 plus 72. So this is nothing but your 50 by 121. So 50 by 121 is what we get. So we should be doing the further calculation. That means we should multiply with this by 15 by 121 with regard to this, and since I have to multiply with 11, so I will also get it done here. So this is my answer over here. Okay, so is this what, if you see, if I take 11 common outside, this is your x square minus 12 by 11x plus 50 by 121. Okay, and if we come back to the previous page, let us see whether we get the same answer or not. X to the power 2 minus 12 by 11x plus 50 by 121 or not. Yes, x square minus 12 by 11x plus 50 by 121. So with regard to e to the power 3x and x square, we have got our answer right. Not only that, we have verified also. Now the question that we would ask is that, do we have so much of time in examination? We do not have. These are all things which you need to do the drill or the trial before appearing the examination, because most of the time it's seen that many students get it very in the first place, the easy questions wrong, and that costs them heavily, and that's quite detrimental to your total tally. Now I'll try to find out particular integral with regard to P2. Okay, so I'll add more page here. Now certainly I've forgotten what was the function, so I will look into the question. All I remember is this t squared by 2, so it is actually e to the power x cos of 2x. Now again, this is also having the same property, that is, you have to use the shifting. Mind you, shifting in ordinary differential equation and Laplace transform are quite opposite. So what we know is that it's not just mere formula. Even in the classes where we trust upon is the fundamentals, that is, how do we derive certain things, because we may remember formula or the magic charm or the formulaic approach, but there's a tendency to forget these things. A better way out is always to find a derivation, rather to get at the heart of how things are done, rather than arriving at the final answer. And making comparative analysis, this is what we focus in at ashram, is that we try to correlate with other topics. Suppose if we are dealing with differential equation, we are not merely dealing with differential equation, we are also having the foresight and vision to have a second order differential equation which has this ubiquity in solving a mechanics problem, because most of these are modeled on second order differential equation. And we also use, when we use in partial differential equation, when we use mechanics course, when we use dynamics course, when we are trying to have an understanding as regards even partial differential equation. So these are the building blocks. They are all written in the language of calculus, and one must have a robust understanding of calculus and analytic geometry to have a solid foundation to take up this optional. So let us try to find this e to the power x cos 2x upon d square plus 2. Now this will also ensure shifting. That means I can write this as cos 2x d plus 1 whole square plus 2 e to the power x. Now this is your cos of 2 to the power x. This is d square plus 2d plus 3. Now we can use the property as regards this, that when we are having this at some factor of whatever, we can place this if denominator is not 0. We're putting is not 0. So e to the power x cos 2x. Now if you would further simplify this, e to the power x cos of 2x upon minus 4 plus 2d plus 3. Okay, so we can use this and write in the next page. P by 2 e to the power x cos 2x upon minus 4 plus 2, so it's perhaps 2d minus 1. So we'll just check it. So it is 2d minus 1 indeed. So we can further write it down. And now this needs a rationalization. Okay. So we can multiply this by 2d plus 1 upon 4d square minus 1. Now this is again minus, you would see minus 16 minus 1, that is minus 17, and this is minus of 2 into 2 on sine of 2x plus cos 2x. So this is our pi2. If you want to write like this, we can say 4 sine 2x minus cos 2x. So we got our complementary function, we got our pi1 and pi2. So we need to club all of these together and present our answer. Okay, so this is how we try to do questions. Now implications are very simple in this chapter, because in this chapter of ordinary differential equation, many a times we have issues with regard to choroids and P discriminant and P's and Q's, and especially on singular solution. And there has been a rising trend in the year after year. They're asking question on singular solutions with regard to especially Claude's equation, and we will be taking all those questions. So this is one of the important building blocks of applied mathematics. If we are having this robust understanding of this topic called ordinary differential equation, we can build our framework not just only in partial differential equation, but also in courses like mechanics, fluid dynamics and dynamics. So this will always hold us in good stead. And there is quite a rumor around that these are core topics of physics, but if you would look into, it's not the physics that will trouble you, but the mathematics of that, and that you can only solve when you have a good understanding of higher mathematics, when you are very well conversant with ideas like calculus, ODE, vector, PD, and all of that. And for that matter, analytic geometry is also one area where people struggle a lot. So this is we want to try to give solutions, because we have our classes in both morning and evening shift. So on all those while we couldn't come up for solution series, but we'll try our best as much as we can. Whenever we have time, we can put up in the public domain some of the questions, and we are focusing on next year batch as well, and we will be announcing a batch which will be having a special batch, not more than 25 to 30 people, serious students, and for 2023. For that I may have to also take a test. I will take that, and that will be a special batch apart from whatever is going in the regular classes. Okay, so that is for now. Thank you so much.